Welcome and thank you for being part of today's WorkSafe webinar, regulating exposure to crystalline silica and prioritising employees' occupational health. My name is Cameron Ling and I'll be your host for this session, and we really appreciate you joining us. Today I'm joined by three WorkSafe experts. Perdita Dixon is Manager of Occupational Health and Operational Programs. Welcome, Perdita.
Hi, thanks, Cameron.
Great to have you with us. Also joining us is Ben Wright. He's the Manager of Earth Resources and Silica. Welcome, Ben.
G'day, thanks.
Really appreciate you joining us. Also here is Halil Ahmed. He's the Principal Occupational Hygienist and he's also an Inspector. Welcome, Halil.
Yeah, thanks, Cameron.
Great to have all of you for this session. This session is going to run for around about 45 minutes in time, and it's going to explore how exposure to dust containing crystalline silica can lead to diseases like silicosis, and will then outline new crystalline silica regulations. After that, we're going to open it up to questions from you, the audience. If you notice on your screen on the right-hand side there, that chat box, that's how you can ask any questions. And go ahead and start entering your questions whenever you like. Type them in, hit enter. I'll have them then ready to go and ask them on your behalf a little bit later on. Okay, let's get straight into it. To kick off with you, Perdita, if you don't mind, what exactly is crystalline silica and why is exposure across Victorian industry such an important issue?
So crystalline silica is a naturally occurring material, and its most prevalent form is quartz. It's in the soil and sand, and in lots of manufactured products as well. It's when these products are processed in ways such as cutting, grinding, and polishing that they produce respirable crystalline silica dust. It is this very fine silica dust that causes harm and can lead to debilitating and fatal diseases such as silicosis, lung cancer, and autoimmune diseases like scleroderma. Products that contain crystalline silica are in many industries. The best known are in construction, quarrying, and mining, but it's also used in manufacturing, ceramics, and even public transportation.
Thanks for that, Perdita. Now over to you, Halil, if I could. The health impacts of exposure can be devastating for individuals and workplaces. What are the health impacts for workers?
Yeah, thanks, Cam. As Perdita mentioned, exposure to crystalline silica can cause a range of diseases. Taking a little bit of a step back, it's really about the generation of the very fine particles of crystalline silica dust into the air, and then the exposure to that dust that can result in an illness. We're talking about use of like power tools on concrete, bricks, cutting bricks, etc. Generation of that dust. And then the amount of exposure that someone has, so to that airborne dust. So we're talking about how long they're exposed to that material, how often they're exposed, and the concentrations during that exposure periods as well. So all those need to be considered. And potentially, as a result of that sort of exposure, you can result in diseases such as silicosis, which is a scarring of the lung tissue, resulting in laboured breathing, harder to breathe, difficulty. It's a progressive disease, so it'll gradually get worse. It's not reversible. So you can stop exposure, but it could potentially, depending on your past exposure, continue and get worse as well. In severe cases, it can actually result in someone's death as well. Scleroderma, which is what Perdita just mentioned before as well, which is a tightening of the skin, usually fingers, etc., hands, fingers, and reduces your mobility, and it continues as well. And then we've got lung cancer and kidney disease as well. And really the emphasis should be on appropriate controls, and always going back to what your controls are to try and prevent those sort of diseases.
New regulations have been introduced by the Victorian government to mitigate workplace risk. What, I suppose, broadly, do the new regs look to achieve, and why are they so important for employers and employees to understand and follow? Perdita, perhaps to you on that one.
Thanks, Cameron. So the new regulations aim to minimise Victorian workers' exposure to crystalline silica, and it does it in a few ways. First of all, people need to know the products they are working with contain crystalline silica so they can understand if there is a potential risk. Because of this, there are now specific duties for manufacturers and suppliers to provide information to users of their products if they contain crystalline silica. This needs to include how much crystalline silica is in them, the relevant exposure standard, and the required controls when working with them. Secondly, duties have been introduced requiring employers to identify if high-risk crystalline silica work is being undertaken. If it is, there is a need to complete a crystalline silica hazard control statement. This will document what the hazards and risks are, what the required controls are, and how they will be implemented. There is a template for this on the WorkSafe Silica landing page. As we know that many construction-related activities will be high-risk crystalline silica work, this information can also be included in your SWIMs if you need one. There are also extra requirements to inform people that they will be undertaking this work and the need for specific silica training. This training will ensure employees are aware of the health effects associated with the exposure to crystalline silica and what controls are required to keep them safe. And thirdly, we've introduced the first engineered stone licensing scheme in Australia. This scheme ensures a number of things, including that those working with engineered stone are provided with the correct controls to do their job safely, that appropriate health monitoring is conducting, and that only those with a license can be supplied engineered stone if they're going to work with it.
Thanks for that, Perdita. That makes a lot of sense. I understand that the engineered stone sector license scheme will be introduced in November. Ben, if I could bring you in now, what should those businesses know?
Well, for anyone involved in the manufacture of engineered stone benchtops, they need to hold a license to operate and to purchase stone in Victoria. And I'd encourage all of those stonemasons to apply before the November 15 deadline. But today we're here to talk about silica and high-risk silica outside of that sector particularly.
Okay, great. Thanks for that, Ben. Perdita, if I could go back to you quickly then, what exactly is high-risk crystalline silica? How do we define it as a workplace hazard?
Thanks, Cameron. So the definition of high-risk crystalline silica work is work that is performed in connection with a crystalline silica process that is reasonably likely to result in either an airborne concentration of respirable crystalline silica that exceeds half the exposure standard, or there is a risk to the health of a person at the workplace. So that sounds a bit complicated, but I find it helpful to break it down into two main steps. Firstly, you need to work out if you're conducting a crystalline silica process. The regulations define these, but they include using a power tool, a material that contains crystalline silica, handling material that contains crystalline silica, or a quarrying process involving materials containing crystalline silica. Then you need to think, will this work result in a person being exposed to a level of respirable crystalline silica greater than half the exposure standard, without taking into consideration any dust controls in place? Again, this is a bit hard to get your head around, but you're working out if the actual task that you're doing meets the requirement of high-risk crystalline silica work, not necessarily how I'm doing it with the correct controls in place. So, for example, if I was cutting concrete with a saw with water suppression, there is no dust being produced, but the actual task of concrete cutting would produce a lot of dust. So before starting the work, you can identify if you are performing high-risk crystalline silica work, or you can conduct a risk assessment to work this out. And we have produced quite a lot of guidance and also an infographic to assist businesses, which you can get through our WorkSafe Silica landing page for this.
Great, thanks for that, Perdita. Halil, if I could go over to you now, what are the hazards particular to crystalline silica that employers and employees should be aware of?
Yeah, it's relatively simple. It's really all about the generation of dust in the air from the crystalline silica substance or the product that contains crystalline silica, and then the ability of people around that to breathe it in. So it's really that pathway or that sort of method of exposure. In many workplaces, we're talking about tools that are being used, power tools, concrete cutting. You know, if you imagine someone cutting concrete on the footpath, if they didn't have water suppression, it'd be generating a lot of dust. So it's all about, so how is the task being undertaken? Will it be generating dust into the air, and will people be able to breathe it in? So use of tools on solid concrete material or solid silica containing materials, but also the use of the transfer of powders, opening a bag. If the product contains respirable fine crystalline silica, the transfer of the dust, the transfer of that product, creating dust in the air to where people are once again being exposed. So and then that's potential health outcome as well. So it's looking at the process and how people might be exposed, which once again brings us back to controls. you need to have controls as close as possible to the source of where the dust is being created. So if we're using a power tool, dust extraction or water suppression around the tool itself where the dust is being created. And that's ideal. Like if you can't eliminate the substance or substitute it to a lower degree, then you start looking through your controls. That's the type of controls that we're focusing on.
So keeping everything in mind there that you're talking about, Halil, what would your advice be to employers around process and those controls that you're referring to?
Yeah, like I think the first step is really identifying if you actually have a crystalline silica process. So as Perdita mentioned, these are identified and they're very broad. If you're working on a crystalline silica substance or containing substance, if you're using products that contain crystalline silica, you'd most likely be generating a level of dust and you'd be undertaking a process that's creating that dust. So you would be undertaking crystalline silica process. The next step is to determine whether it's high risk crystalline silica work. And that's where exposure is likely to get above half the standard, as Perdita's also mentioned, without taking into account any controls that you've got in place. So most tasks are generally going to fall into a high risk crystalline silica work. And then if it does, then you have to create what's called a long-term crystalline silica hazard control statement, but it's the equivalent of a SWMS. So a lot of people out there are familiar with SWMS, so it's not something really new in that sense. So that's worth keeping in mind. Now, the other thing that I'd like to emphasise is there's a control hierarchy that needs to be implemented as well. So not just your paperwork or your SWMS, etc. It's really looking at exposure and then establishing and working through the control hierarchy. Can you eliminate it? Usually if you're cutting concrete or doing some work on a particular substance, you can't. So then you look at, okay, what are the controls? Working down the controls. If you can't substitute, then you look at elimination. That's engineering controls, as I mentioned before, on-tool extraction or wet suppression directly around the source. And then if you work for that, and then your last option, and it is your last option once all the other controls have been implemented, is personal protective equipment, such as respirators in this case. The other thing that I want to touch on is air monitoring. Air monitoring may be required, and we're talking about personal monitoring, attaching onto an employee's collar, letting them undertake their work, where there's a little bit of uncertainty. Say you've got controls in place and you're still unsure whether exposure is likely to exceed the exposure standard, then you can engage an occupational hygienist to come along to undertake that air monitoring and provide you with the information as to what level of exposure and whether additional controls are required. And finally, I just want to touch on health monitoring. And health monitoring is not always clear. It's where an adverse effect is likely to be the outcome. And we generally try and interpret that against the occupational exposure standard for crystalline silica. So if it's likely that someone's going to be exceeding that standard, regardless of any respirators that they're wearing, that's when employers should be looking at undertaking health monitoring of their employees. Yeah.
Great, thank you for that, Halil. I suppose I start wondering, what does this all mean for the quarry sector? Ben, if I could go back to you on this, any lessons to be learnt from them or insights here?
Thanks, Cameron. Well, the quarry sector, it's in a different place than the engineered stone sector, because silica has been a recognised hazard in this industry for a very long time. That doesn't mean the sector's perfect, and there has been some recent silicosis claims in that sector as well. For quarrying and mining, the new legislation means a renewed focus on this as a hazard and to drive that continuous improvement for what is the old hazard of silica. Lastly, it's an acknowledgement that the quarry sector has a role to play in helping their customers reduce risk in relation to silica exposure. And this is through the supply chain obligation that we've spoken about, where the silica content of the quarry material is to be provided to customers at the point of sale. This will help those in construction and other customers who purchase that material identify that risk and understand it as a hazard.
Ben, I'd love to stay with you on this one. We've talked about the new regs. How is compliance going? And have you got a good case study here for us by way of example?
Sure, Cameron. Our current focus is on quarries with a high silica content in their material. This is where the highest risk exists, and it's also where the claims that we have seen exist. We are seeing small operators working really hard to comply with the new legislation, and that's being really well supported by the industry bodies such as the CMPA and the CCA. One good news story we have from a small quarry in the east. They were working through their crystalline silica hazard control statement. They partnered with their industry group, and through that partnership, they ended up connecting with a supplier who could retrofit their crusher plant with a fully enclosed and filtered cabin area. The benefit this had immediately was it removed the reliance on lower order controls, such as their exclusion zones. It removed the requirement for PPE in that area, and it even took away the daily shaving obligation for the gentleman who worked in that area. So really positive outcome, a higher level of control, and now that quarry plant is somewhere people want to work and can work safely.
A great example. Thanks for that, Ben. Really appreciate it. Perdita, if I could jump back to you again for a second. In summary, what would your messages be to all industries and organisations working with crystalline silica?
Hi. I think firstly, it's around understanding the new regulations. So get on board with them, understand what they mean for your workplace and that industry and the tasks that you're doing. And really importantly, remembering that these regulations have been introduced to keep Victorian workers safe. So know your responsibilities, and really importantly, communicate with your staff, get them to understand why these new requirements are being brought in, that it is around their health that we're looking at these new regulations. And really importantly as well, go to the WorkSafe website. So we've got a silica landing page there, and there's a lot of resources available for different industries. We've got templates, we've got guidance. And if you need further support as well, you can also call the WorkSafe advisory line.
Great. Thanks for that, Perdita. I really appreciate your insight, and yours, Ben, and Halil as well. I can see that working with crystalline silica doesn't need to be a potential workplace harm. You gave a great example, Ben. If employers follow the regulations and guidelines, they can mitigate the risks for the workers. We've got a lot of questions coming through, which is fantastic, from our audience. I want to get to those so that we can do some deep dives into whatever area people want to know some more information about. Please, any or all of you jump in on any of these questions. I'll try and direct them as best I can, but a lot of people wanting the answer to this one. What is the actual regulation around being clean shaven for respirators? What if a worker has a beard and passes their fit test? Would they still need to shave? Who's best to answer that one?
I can probably take that, and others can jump in if they would like. It does come back to, I mentioned the hierarchy of control and how people really do need to start at the top and respirators are at the bottom, and I'll get to the fit testing bit, but respirators are at the bottom. So you start, can I engineer it out? Can I isolate it? Can I do other tasks? And if you've done all of that, then you start looking at respirators. And if you're relying on respirators to control your exposure, that's part of your controls, and part of the requirement for tight fitting respirators where you're relying on a seal around your face is that you need to be clean shaved. If you've got, some workplaces can have powered air respirators that don't require a tight seal, and you really do need to understand the powered respirator that you're using if that's the case. And so you don't need to be clean shaved with those respirators. But if you have a tight fitting respirator, what's called a negative pressure type respirator in particular, you do need to be clean shaved.
Great, thanks for that, Halil. Perdita, would you like to add something to that? Can I?
Thank you. That's all right. I just wanted to reiterate what Halil said around the hierarchy of control. I think it's a really important discussion, and one that we're having all the time, that it is really important that businesses look at that hierarchy of control, and you're identifying if you can use any higher order controls, such as particularly engineering controls, to reduce that risk so that there isn't that reliance on respirators. I mean, that's very clear in the regulations. The Hazardous Substances Compliance Code also talks to it really well. But duty holders, employers really thinking up the hierarchy of control will be a big thing coming out of these new regulations as well.
Great, thanks, Perdita. Again, a lot of people asking this question, and I hope I get the pronunciations correct. Help me if I'm not, and guide me a little bit if you don't mind. How do you know whether or not there is a respirable crystalline silica risk when you are cutting concrete? Who's best to handle that one?
I can start again, and then others can jump in. Really, there's Google search is a wonderful thing, but in terms of cutting concrete, if you're undertaking any task where you're using a power tool on something like cutting concrete or bricks, you'll generate a range of dust sizes, which will include respirable fraction in that material. So use of a power tool on any sort of solid product will generate a level of respirable dust. If there's any uncertainty about the level of exposure, though, it's going back to personal air monitoring, engaging an occupational hygienist to undertake that personal air monitoring.
Perdita, go for it.
I was also going to say that we've got some guidance which is on dust-containing crystalline silica in the construction industry, and that's got a really handy table in it that talks about some common construction materials and how much crystalline silica is within them. And as Halil just said, once you start to cut it, you're likely to produce dust that then has that respirable proportion in it. But again, back to those new duties on suppliers and manufacturers, that's why it's so important for people to know if those products have got crystalline silica in it, so they can start to think, hey, I'm about to cut it. This is going to produce dust. It might now have that respirable crystalline silica in it.
Great, thank you. This next one, I think I'm directing to you, Ben, but please correct me if I am wrong. Do excavators create silica dust whilst digging and hammering through rock?
Good question. Look, we'll get back to the basics again. Understanding the silica content of your material is really important in this instance, but fundamentally silica is very prevalent in the soil and in a lot of rock. So simply digging, if it is quite damp, for example, the exposure might be quite low and the dust liberated might be low. And thinking about how far away people might be from that work as well will also affect their exposures. Certainly, if you were using it to break rock with a rock breaker, or in the demolition sector, for example, using a jackhammer attachment on an excavator, we do know that when there is silica content in that material, that process will be liberating quantities of silica-containing dust.
Great, thank you for that one, Ben. Again, a lot of people asking this question, and I think I'm directing it to you, Halil, but again, correct me if I should be asking someone else. Is a hazard control statement required where a SWMS has been prepared that identifies the RCS hazards and states the controls?
Simple answer is no. It's really, if you can cover it all in your existing SWMS, and it's not that difficult. It's respirable crystalline silica is likely to be generated. What is the hazard? Inhalation risk. It can cause silicosis, etc. And then identifying what your controls are, so that sort of an employee comes along, picks up your SWMS, and sees exactly what the control should be in place, and they review it. And yes, it's all fine. So simple answer is you don't need an additional hazard control statement if it's covered in your SWMS.
Great, thank you for that, Halil. Perdita, I think I'm asking you this one. How can we know how much work will create a significant silica risk, e.g., say when cutting bricks or drilling concrete?
So when you're looking at the tasks that you're undertaking, Halil mentioned that there's things that you need to consider. So, for example, how long you're doing it, what's the period, what's the frequency of undertaking that task. And there is information that you can potentially gather, and there's resources that are available through the internet. But Halil also talks about air monitoring and that uncertainty. So if you're undertaking a task and you are uncertain whether the exposure is above the exposure standard or not, that is potentially when a duty holder will start to think, or an employer will think, do I need to do some air monitoring? Do I need to engage an occupational hygienist to put a pump on the workers, so that it's really understanding what that exposure is for the task that's being conducted?
Yes, Halil?
It's worth remembering that you can always deem a task to be high-risk crystalline silica work as well. So because engaging someone to do air monitoring is going to cost money. Whereas if you implement a control, it might be the equivalent, it might be a bit less in terms of the control. So you're reducing exposure regardless of whether you are absolutely high risk or it is a risk of a lower level or not as well. So it's worth remembering.
Yeah, great point. Thank you for that, Halil. This next one is a really specific one, and one I had absolutely no idea about. So I'm intrigued as to who handles this one. Trams use crystalline silica in the braking sand. Are there any safe alternatives out there? Who wants that one?
Well, I don't know. I don't work in the industry, but I think there is this process of when you look at substitution or elimination, through your consultation processes, understanding what the braking process is and what that fundamental requirements or properties of the silica containing material is currently, there is that opportunity to consider, can I completely eliminate a product that doesn't have crystalline silica in it, or is there opportunities potentially to look at a lower percentage of crystalline silica in that product? But I might pass on to the others and see what others have on the thoughts.
Well, the only thing I'm considering is the practicability of the situation, and as you know, practicability has got a number of factors. The level of risk. What is the risk to persons that are undertaking the task, and what is the cost associated with alternatives? They're two factors, not the only factors, but they're two factors that need to be considered. So potentially it could be, but it's really balancing all of that in the consideration.
Great, thank you for that, Halil. And Perdita, this one I think is to you, Halil. If I get a hygienist to do air monitoring for silica, should I provide the results to my workers even if the results are good? How do I do this?
In terms of providing the results, yes. Sometimes what we talk about with employers is it's sometimes worthwhile getting the consultant back to explain it in front of the employees, and then if they've got some questions, they can ask it directly of the consultant that undertook the air monitoring. I think it's you're required in terms of legislation to inform employees of this sort of monitoring, and it's really, if they can be engaged as much as possible to convey the information, then it's easier for them to understand why certain controls need to be in place, and more likely that they'll implement those controls and maintain them as well.
Great, thanks for that, Halil. Ben, I think you mentioned personal air monitors, so I might ask you this one, but please, anyone else jump in if need be. We're struggling to find personal air monitors for crystalline silica. Can you provide some suggestions?
Look, I'm not the hygienist in the call, but I'll happily take this one. Through the Australian Institute of Occupational Hygiene, there is a Find a Hygienist tab on that website. So I'd encourage everybody to engage through that website and utilise a local hygienist. They're the people that can supply this equipment and make sure the tests are carried out properly.
Great, thank you, Ben. Anything to add, Perdita or Halil?
Yeah, look, I'm not sure whether they're talking about instruments for them to use themselves. I think if they are, some real understanding and training of that instrument or the use of that instrument is required. So you generally go back to the group that Ben mentioned, the Australian Institute of Occupational Hygienists, and have one of their consultants utilise that instrument, or at least educate the workplace on how to use it as well.
Great, thank you for that. This one's probably a tricky question, and it's around, I think, the term practicable, as you mentioned before, Halil. Will workers now have to have controls in place every time that they drill into brick or concrete? For example, to put a 6mm plug into a brick?
And it's a little bit of what I mentioned before as well. Like you want to minimise exposure, full stop. But it does come back to what is the risk associated. Like if my job is drilling holes into the ceiling of a newly constructed building to install cabling for electrical wires, and that's all I do all day long, then absolutely you need controls in place to do that. If I'm coming along to drill one hole and then I'm going to go off to another task or another workplace to do something totally different, then it's not as critical, because the exposure is not going to result in a real risk. But it has to be looked at in the whole of what I'm doing and in the context to say what's the likely level of exposure and hence the likely risk to employees.
And And I was just going to add to that as well. I mean, in the last few years, we've seen a significant increase in availability of things like on-tool extraction. These tools are available in a lot of shops now. Class M, Class H vacuums are really commonplace. Previously, these were Class H were really just for the asbestos removalists. We're seeing them far more available for all tradespeople because of this awareness with crystalline silica. So something that was potentially less practical a number of years ago because these items and these tools just weren't as readily available as they are now are becoming more practical. So it's really thinking about these businesses. If this is your task that you're undertaking every day, all day, are these tools, are these controls that you should be getting? And there's a lot of them available now in different places.
Great, thanks for that, Perdita. This one, I'm not sure who this one's going to, so please jump in. Is there an expectation to conduct soil testing before commencing excavation works and loading tippers?
I could probably take this one, Cameron.
Thanks.
So there is if it's from a quarrying process. So there's now an obligation if you are doing tunnelling or quarrying that you do need to determine that silica content prior to commencing that task. However, and also if you are a supplier, so if you are excavating that material and then on-selling it as a supplier, those supply duties will trigger and you would have to supply the silica content of that material. However, if you are excavating some material and transporting it, not in a supply capacity, there isn't an obligation to determine the silica content. Keep in mind that if you do know that the soil type you're in, it can be appropriate sometimes to use the range of silica content that is commonly known or available for that material.
Great, thanks for that, Ben. Next one, again, a lot of people asking this question around exposure. Is there a regulation on health checks / monitoring for employees who may have been exposed to silica dust?
I can take it and others can jump in along the way. The regs are about, in terms of the health monitoring reg, it is about likely adverse health effect as a result of that exposure. And there's no direct interpretation in the regs, but the way we generally interpret it is if you're likely to be exceeding the occupational exposure standard, regardless of any respirators that you're wearing. So if that's the situation and it's, let's say, ongoing, then health monitoring is absolutely required for crystalline silica. There's not a requirement that if someone was exposed to crystalline silica in sort of 2 weeks ago as a result of an incident, there is no regulation that covers they must be now provided with health monitoring. It's all about what's happening at the workplace and is it ongoing as well, that sort of health monitoring requirement.
Great, thanks for that, Halil. Perdita, did you have something to add to that?
I think it's worth noting as well that obviously we've got new crystalline silica regulations, but the control of risk and the health monitoring regulations aren't new. These regulations have been in place for, I don't know, a long time. Halil probably knows exactly how long. And health monitoring can be quite a complex area for people to understand. So it's really understanding if your employees are, need that health monitoring because of that kind of exposure they're getting at the workplace, and then really engaging that registered medical practitioner to assist with the health monitoring process.
Great, thank you for that. This one, I think, is going to you, Halil, but please jump in, whoever it might be. How should dust from RCS processes be collected and disposed of?
Yeah, like the collection, we're really talking about something like a dust class H or dust class M vacuum cleaner in terms of dried dust that's settled around in workplaces. You can use water methods as well, wet methods, to try and collect of the material itself. There is no EPA specific requirement for the waste to be disposed of at a certain landfill. But it should be appropriately wrapped so that if someone is picking it up or unloading it from a large bin, that the bag doesn't rip, that people aren't exposed to it in that process as well, so that when it ends up going into a landfill somewhere, it's not going to cause a risk of exposure to other persons as well.
Great, thank you, Halil. A couple of questions here coming through around air monitoring. How often do we require for air monitoring to be done in the workplace?
I can take it, but others can jump in as well. The regs actually do specify, they don't specify frequency, but they specify where there's uncertainty, air monitoring is required. Now, someone can do it more often, like to confirm their controls. They might be quite happy with their controls, nothing has changed, but they want to do monitoring on a frequent basis. That's absolutely fine. But the regs talk about uncertainty, and uncertainty can result when something changes in the workplace, like the number of employees working in an area has increased, the process has changed to result in potentially greater exposure. A different product has been introduced that contains crystalline silica. So you do have to be conscious of your work environment and what's happening in terms of the products and how it's happening, and then that may kick in the need to do additional air monitoring.
Perdita, did you have something to add to that?
No, I was just really agreeing with what Halil was saying, and I think it's that really bringing in the consultation process as well. Like if there is changes happening in the workplace, utilising those consultation mechanisms to, the HSRs or the employees assisting with understanding if there is a change and if now it has become uncertain what that potential exposure is.
Great, thank you for that. And continuing with the air monitoring theme, a lot of people just have added this one. What value add is air monitoring if employees are working out in the field at different locations where product and potential exposure will differ?
I'd like to jump into that. So I would say if you can identify a control and implement it, and that can be adapted from workplace to workplace that they're going, that absolutely controls the risk, let's say, and there is no uncertainty, go down that pathway. It's absolutely not necessary to do air monitoring where you've controlled the risk. And if you're doing air monitoring, it's going to cost anyway. So better to put your energy and your money into on-tool extraction or water suppression on the tool so that the employee undertaking the task isn't exposed to a risk. So I think employees should be trying to look at it that way, to try and not have the cost of air monitoring, because subsequently, if there is a risk, you'll have to implement a control anyway.
It's a great point, and I think the next question might flow on to exactly what you're just saying there. How do you undertake personal monitoring for silica tasks that are very short in duration, e.g. 2 to 5 minutes, and are only undertaken periodically? You're suggesting put the controls in place and the monitoring's not as important.
That's right. Yeah. And it is difficult to monitor for short periods to come up with a constructive number as well. I'd say you could engage a consultant to give you some advice. They don't necessarily have to do the air monitoring. They might have a look at the task and understand how frequently and how often the process is undertaken and say, look, go to your control. Don't bother doing air monitoring in this sort of situation.
Fantastic. Thanks for that, Halil. Still a lot of questions coming through. I'll try and get to as many as I possibly can before we run out of time today. This one, quite a few people are asking. A lot of dust is evident in construction sites. Will WorkSafe be looking to see dust being vacuumed from works instead of sweeping due to silica exposure? I think talking about cleanups there, instead of using a broom, using a vacuum.
I'm happy to start with this one and others can join in. I think it's really looking, again, we've spoken about individual tasks and how long and kind of what that task looks like. But as a general kind of comment, if we're sweeping, and I've definitely seen some interesting information around what kind of levels can potentially be generated during sweeping. If this is a risk that's being generated, it needs to be controlled. And, quite obviously, instead of sweeping, using vacuums is a really good control, potentially using water, but vacuums may be the better option for that situation. So, depending on the task, depending on the construction site, vacuums may be, what we're trying to look for instead of the sweeping in those spaces.
Great, thanks for that, Perdita. A couple of questions here I think are going to be related, so I might ask them together, join them together. One person asks, I don't feel I can assess the size of risk. Do you have a simple tool so I can schedule work to minimise risk and still get work done? Bob also then asks, is WorkSafe Victoria producing any further comms to help with businesses understanding and identifying high-risk crystalline silica work? I think both of those questions just asking for assistance and simple tools to help them.
Well, there is work happening to try and come up with some further guidance for employers in this sort of space. I don't know if there's an existing infographic that Perdita mentioned earlier that directs people into whether controls are required, whether swims are required, etc. So that's worth having a look at on our website. In terms of other tools, maybe Perdita or Ben can jump in there, but I'm not sure. But I think it's really, is your process generating dust? Like having a look at your process, understanding if it involves crystalline silica to start with, understanding that the dust that's generated will include crystalline silica respirable, and then if that's the case, you know that you should be looking at your controls. The exposure standard for crystalline silica is low, is very low. So chances are, if you do this in any frequency and for a short, even relatively short period of time, chances are you'll need a control. So, and as Perdita said, on-tool extraction, wet suppression, much more commonly available now. So the obstacle in trying to introduce those sort of tools or obtain those sort of tools is not what it was 5, 10, 15 years ago.
The last thing I'd leave there, Halil, is that there's a lot of guidance material more broadly than just from Victoria. The exposure standard is national, so Safe Work Australia has some good guidance. Other jurisdictions also have really good resources, and that could be videos or tools. So I'd encourage you to broaden your search as well outside of Victoria.
Fantastic. Thank you very much. There is a lot more questions that I could get to, and I'm going to, unfortunately, have run out of time. We really appreciate so many from our audience who've joined us today, but also have asked those questions. Anyone who is asking those questions, we keep a record of them so they can be reviewed, those questions. But also, if you need immediate advice, please don't hesitate to get in contact if you need an answer to your particular question. Well, thank you so much to the three of you for joining us today. Perdita, really appreciate your insights today. Thanks for joining us.
Thanks so much.
And Ben, thank you to you too. Really appreciate you coming on and giving us your expertise.
Thanks, Cameron. Thanks, everyone, for attending on a Friday afternoon.
And thanks also to you, Halil. Really appreciate you coming on for your insight today.
Yeah, you're welcome.
It was great to have the three of you on. Well, we hope that everybody who joined us found this interesting and informative. This webinar will be available online on WorkSafe's website next month, so that you can view it at any time if you just need to check up on a couple of little things that you may have missed. Also, we will be sending out a survey. We really appreciate any feedback we can get to make sure that we're delivering the types of webinars or workshops that can help get that key message across about staying safe in the workplace. So please fill in the survey, get it back to us, and we'll use that feedback. But you could also win something. One of 5 $100 gift cards will be coming your way if you are one of those lucky winners. Winners will be notified by the end of November via email or a phone number, depending on what you supplied. So please get them back to us. And we will note on the screen shortly a list of the contacts that we've talked about today that you may find helpful if you're working with crystalline silica. And if you have any requests for further information, as I said before, please get in touch with us. It's really important. And if there is something you want to discuss urgently when you're at work, please contact the WorkSafe advisory line. And don't forget, the emergency line is open 24/7. Well, this is the final webinar of Health and Safety Month. We've had a fantastic month, either via online platforms or also been getting out to as many different places as we can. Bendigo, Narre Warren, Ballarat, Horsham, Portland, Warrnambool, Port Fairy, just to name a few. That message is getting out there, and we do appreciate so many people taking time out of their day to join us and learn more. Thank you so much. All the best. Stay safe.